Welcome to myprojectwizard.com. This is our project title, a model for examining the role of nodal attributes in dynamic social media networks. And this is our project abstract. The project abstract is social media networks are dynamic. As such, the order in which networks ties develop is an important aspect of the network dynamics. The study proposes a novel dynamic network model, the nodal attribute-based temporal exponential random graph model, the NATERGM, for dynamic network analysis. The proposed model focuses on how the nodal attributes of the network affects the order in which the network ties develop. Temporal patterns in social media networks are modeled based on the nodal attributes of individual and the time information of network ties. Using social media data collected from a knowledge sharing community, empirical tests were conducted to evaluate the performance of the NATERGM on identifying the temporal patterns and predicting the characteristics of the future networks. Result showed that the NATERGM demonstrates an enhanced pattern testing capability and an increased prediction accuracy of network characteristics compared to benchmark models. The proposed NATERGM model helps explain the role of nodal attributes in the form of process of dynamic networks. This is our data flow diagram of our project. First, start the program and load the dataset. The dataset related to the social network, which is having the nodal attributes and the networks related to the project. After loading the dataset, the dataset must be an array data or unnecessary data. We have to pre-process the data. After pre-processing the data, we have to send it to the further calculation for finding out the NATERGM process, NATERGM nodal attribute temporal calculation. The calculation, first we calculate the reciprocity. The reciprocity contains the feedback and the response, who having the higher tendency to having the feedback and the response. After calculating the reciprocity, then calculating the transitivity. The transitivity having the 9 set of selections calculation for finding out the nodal attributes in the temporal NATERGM temporal calculations. After transitivity is find out, that then calculation is completed. Then calculated the K out star. K out star contains the two different calculations for finding out the K out star nodal temporal activities, and after completed, it will be calculated K in star calculations. After K in star calculations, having also the two different calculations. After completing the two different calculations, and calculate the cyclicity. The cyclicity in the sense the nodal which are the nodes having the high tendency to related the cyclic relationship between the other nodes. And after completing all the calculation of the NATERGM patterns, and the then after completed all the calculations, and we view the report of all the NATERGM patterns after completed, and then stop the program. Now we are going to see the demo of our project. Click on the home.java and right click on it and select run file to run the home.java of our project. The home page is running now, and the home page screen will display in the window, and click the button to next and browse the dataset. For finding the dataset, we have to select the online retail dataset, online shopping dataset, and load into it, and load the data set into the database, and the data set in the display on the screen, and click the next button and pre-process the data, and the pre-processing will completed and show the data. After pre-processing, the unnecessary data are removed, and after completed the responsiveness calculation, we have to enter into the NATERGM process, finding out the high tendency feedback. The finding will be finding now, and the high tendency nodes are displayed on the screen, and the values of the feedback compared to the original data sets and the result data set, and the response will be calculated. After the response will be calculated, the response total number of nodes on in the screen, and related to the process, and we have to come into transitivity. The transitivity having the total number of time process. After first we find out the bridge having to find out now, and finding now, and the finding now from the results on the screen, and we find out the co-supporting, and after it's bridge values, bridge nodes in the data sets, and after completed co-supporting is also finding out, and the values here, and the nodes are, and the number of nodes in the database are also displayed, and the co-supporting nodes are also displayed in the screen, and the values are displayed in the screen. And go back to, and find out the remark supporter. It's also a transitivity. Find out the remark supporter. The remote supporter are find out the screen, and after find out the screen, the value of the remote supporter, and what are all the nodes which is available in the remote supporter, and the remote supported also here, and the remote supporter also here. We have to find out the finding here, and what are the things we have to. And the result nodes, the network nodes also displayed here, and the remarking supporter also we have to find the remarking supporter. These are all the remarking supporter which is in the data. In the networks, we have to predict networks. After that transitivity, having that remarking supported and follow-up reference out the here, and to find first we find the remarking supported. The remarking supported is values nodes are here, and the values are here, and the find out the follow-ups. The follow-ups find out the it's a known it's a values and node attributes of the follow-ups, and the values are here. Follow-ups values are here, and finally now we find out the reference values and its and the attributes in the database. And now we find out the k out star, and find the k out star in the prioritization, who are the high tendency to prioritize the attributes. It's in the nodes, and the values of the total nodes, and deprioritize. It's a total reversible to do that. We prioritize node in the case k out star, and click next button, and it's the k in star. First find out the initiative. Who is the initiative of the process, and the nodes, and who is the laziness. These are all the laziness nodes in the database dataset. And so finally we find out the cyclicity having the reversed reference, and find out the reversed reference. It takes minutes to these are all the reversed reference in the node, and the values of the reversed nodes are here, and find out the reversed follow-up. Here we have to find out the reversed follow-up data, and finding out the reversed bridge. Who are the reversed bridge of the cyclicity. So totally it's a cyclic relationship between the one node to another node, and we will find out. And finally we get the NATERGM report. Get the report after we have to all the report in the one cycles. We have now we displayed the what are all the things, what are all the calculations we find out in the NATERGM process with a given the network database, and close the window. Thanks to listeners.